Welcome to qnawire.
Over here we're going to have a certain reaction in which we're going to have the decomposition of ammonia on a metal surface, giving the following data. We are having different initial concentrations for NH3 and different rates. So the method, in order to know what is going to be the rate equation for this reaction, we are going to need to know the order with respect to concentration of NH3. In order to do so, we're going to consider two different rates. Let's take rate 1 and rate 2, whichever ones we want. And recall that the rate for a reaction is going to be equal to K times the concentration of NH3 for experiment 1 times the order of the reaction. I'm going to call the order of the reaction A, divided by K times the rate constant is going to stay the same, times the concentration on the second experiment elevated to the same value of order of reaction. So what you're going to notice here is that K and K are going to cancel out, and we can write this down directly as concentration of NH3 on the first experiment divided by concentration of NH3 on the second experiment, and all of this elevated to the order of reaction. So we're going to employ the information over here in order to get the values. We're going to employ this rate as rate 1, and this is going to be rate 2. Notice already that the rate is not going to change, so that is already telling us that the value for A is going to be equal to 0, right? So what you're going to see is that rate 1 divided by rate 2 is going to be 1.5 times 10 to the minus 6 divided by 1.5 times 10 to the minus 6 is going to be equal to 1, and this needs to be equal to concentration on the first experiment, which is 6 times 10 to the minus 3, divided by the concentration of the second experiment, which is 3 times 10 to the minus 3 molar, elevated to A. So what we know from here is that 1 needs to be equal to 2 to the A. What is the order of the reaction? A needs to be equal to 0. So the rate law that we're going to have is going to be equal to K times concentration of NH3 to the 0, which is directly K. It's going to stay constant. So now determine the rate constant in mole per liter per hour using data from the first column. So we already know that the rate is going to stay constant, so the result is directly 1.5 times 10 to the minus 6. Regardless, this method is going to be useful to you to determine the order of the reaction for whatever system that you have. So this is called the initial rate method, and it is super useful in kinetics. In this case, it wasn't necessary because the order of the reaction was already 0.